Hi everyone, so we are going to continue today here about optimization problem, how to solve optimization problems. So let me summarize what I gave you last time. What I gave you here, we have to know the variable, what is your unknowns, and what is your objective functions here. What is your objective function? Try to minimize, maximize something, right? If they ask you what is the greatest or smallest or the maximum here, so when I say greatest or smallest means I'm looking for absolute min or absolute max, and then you have to find the domain which is kind of closed interval. So that is kind of a hint. So let me show you how to solve here the rest of this problem. Here we solve up to number 3, I think. So let me start number 4. So here again, when you read the problem, you start to read by look for the question mark that you have. Oh, here is a question mark. So they tell you what rent should be charged to maximize revenue. So here I need to get the maximum. So our goal here is to get the maximum here revenue, right? Maximum revenue. So that is our objective functions here, which is maximize the revenue here. So what is the revenue formula here, guys? The revenue formula here is the price multiplied by quantity. Price multiplied by quantity, right? So now I have to read the problem here to see where is the price and where is the quantity here, right? We have a hotel here has 10 luxury unit. During the peak of season will rent out at $300. So $300, that is, you have 10, all of them, but also you have, look what you have here is from experience management, know that one unit, it will become vacant for cash $50 increase, right? So here I'm going to, since you have, look what you have here, they tell you one or each unit. If you have one unit vacant, so I'm going to assume X here, that is number of vacant rooms, number of vacant room, because I don't know how many rooms they are vacant, right? So how many vacant rooms here, so that is our X. So now what is the quantity here? The quantity here, you have 10, right, minus X, right? The whole numbers of rooms, you have 10, but you may have some vacant rooms, so it will be minus X. So that is the number of room, right? So that is the quantity I have, the total 10 minus whatever they are vacant, and that is that will be our number here, or our quantity. So the price, what is the price? Oh, $300 plus the other one, you have to the vacant one, it will be 50 multiplied by X. 50 multiplied by X, because why 50 multiplied by X? Because you have we don't know how many vacant, right? So you have X here, the vacant, it will be increased by 50. When you see increase, where is increase here? Oh, increase here means it will be plus. So you plus 50 multiplied by how many vacant you have, and that is give you the price. All right, so that is a difficult part here. That is our revenue. Yes, our revenue here is the price, quantity here, it will be 10 minus X. Though go ahead and simplify this before you take how to simplify this one here. So just expand the bracket, you get 3000, expand the bracket, 3000 plus 200x, right, minus 50x squared. I give this equation number 1. That is my R. Your R here is function in X here, where X is quantity, right? What is your goal? Your goal to get the maximum revenue, maximum. So maximum means I have to get a stationary point, a critical point. Do we have critical point? Critical point here is we don't have do we have singular point? So what is your derivative? I need to get the derivative. So the derivative here, what is the derivative of this? What is the derivative of 3000? 0. The derivative of 200x, it will be 200, minus the derivative of x squared, you get 100x. I call this equation number 2. If I look to the derivative here, guys, you will see that is polynomial of degree 1. So the derivative always exists for any real number x. So because of that, I don't have no singular point. So now the question, do we have a stationary point? Yes. How to get the stationary point? Go ahead and solve this one here. So what you have here, you just equate the derivative to 0, right? So if I do that, so what do you have? You have 200 minus 100x. So what is your x? It will be 200 equal 100x. 0 cancel with 0. So what is your x? Your x is equal to. So now let me ask you the domain. What is the domain? What is the maximum number of room you have? We have 10 room. 10 room. So if 10 room here, what is your x here? So your x, the domain should be start from 0 to 10. So the domain here should be 0 to 10, because the maximum room you could have, you have 10 room, right? You have 10 room. That is one way. Or the quantity here, what is the quantity? 10 minus x should be greater than 0. Should be, so 10 minus x, that should be greater than 0, right? Should be greater than 0. And then what you have, go ahead and solve this one here. So you have 10 greater than x, but you know x must be greater than 0 because that's a number of rooms, so you have be greater than 0. So the domain here should be 0 to 10. 0 to 10. All right, so now what is, I have to finish this. I make a table here. I'm going to make a table here, right? And then you have here x, and you have here r of x, and then you have 0 here, you have 10 here. And what is your stationary point? 2. Your stationary point here, 2 and 2 inside the domain. 2 here is inside the domain, right? So now I need to get, I go back to r, I need to get r of 0, right? What is the value of r of 0? And I need to get the value r of 2, and also I need to get the value of r of 10, right? So how to do that? I go back to equation number 1. Where is equation number 1? Here. Look what you have here. Just go ahead and replace x by 0. If I replace x by 0, what did you get? If I replace x by 0, you are going to get here, just replace x by 0, replace x by 0, get 3000. So I write here, when you have 0, you have 3000, right? So 3000. So why you can ask a question here, why I took x equals 0? X here should be greater than 0, right? But also it could be 0. 0 means there is no number, there is no vacant room. There is no vacant room because the total number is 10, and you could have x could be 0 because means there is no vacant room, right? So that is what that is the reason I consider 0 here. So now I need to go back to r of 2. So I go back to equation number 1. You have 3000. So 3200. 200x. What is your x? Multiply by 2 plus minus 50. 2 square. 2 square. So that is come from equation number 1. Look what you have. Just replace x by 2. Replace x here by 2. Then that's what I did. Use technology to get the number here. So what did you get? I got here 3200. So that is 3200. So I write here 3200. What is r of 10? It turned out is 0. Just go ahead and put it in equation number 1. Just replace x by 10. Replace x by 10. It simplify. You get 0. All right, you get 0. So here I got 0 here. So when I look to the table here, what is the smallest value you have? That is your minimum. The highest value you could have, that is absolute maximum. So your global max is, I should maybe write it down here. So our global max, I should write it here. Global max is what? Global max is, that is the global max of your revenue, right? Of your revenue here, which is 3200, right? When x equal 2. What is x equal to? Means you have 2 vacant numbers, 2 vacant rooms. You have 2 vacant rooms. Okay, so that is very much number 4 here, guys. So the difficult part here is how to get the equations, set up the equation as I did here, and then the rest here it will be easy for you to proceed. All right. So now if I look at number 5, suppose that in the previous problem the cost maintaining cleaning rented of lecture room was 100 per day. What is the question? They ask you what is the maximum profit. So the question here is maximum profit. So what is the profit? How to get the profit? The profit here should be revenue, revenue minus cost. What is the total cost here? So the total cost, we should write the total cost. The total cost here is, you have $100 to clean rented luxury room was 100. So and the cleaning a rented luxury room was $100. So the cleaning 100. So how many? What is the cost here? It will be 100 multiplied by the number. What is the number here, guys? The number here is 10 minus x. So that is the number here. So 10 minus x. So that is our luxury room. So the number of rooms here, it will be 10 minus x. What is the revenue here? That is come from equation 1. What is equation 1? Let us look to the up here. I'm going to use the same equation number 1, which is 3,200x plus minus 50x squared. So I have to use this one here. So you have 3,000, right? I'm just copy from up, 200x minus 50x squared, and that is our revenue, right? And that is minus the total cost, which is 100 multiplied by the number of rooms, which is 10 minus x. If I simplify these equations, I just go ahead and simplify. So you have 3,000 here, and here 100 multiplied by 10, you get 1,000 minus 1,000 with 3,000, you get 2,000, right? 200x, and here minus 100 multiplied by negative x, minus 100 multiplied by negative x, you get plus 100. So if I want to simplify this slowly here, it's okay. 200x minus 50x squared, it's 200 here, right? That's 200, right? And minus 50x squared, and this one, it will be minus 1,000 plus 100x, right? 100x. So now if I simplify this, 3,000 with 1,000, you get 2,000 here, 2,000. 200x with 100, you get 300x, right? And minus 50x squared. Let me give you this number equation. That is that's the profit here. That's the profit. That is the profit here, right? Just write you. That is the profit here. So I'm just writing this. So that is the profit. I need to get the maximum profit here, guys. The maximum profit, just you take the derivative of the profit. You try to see if you have derivative here, the critical point. What is the derivative of this? It will be 0. Derivative of 2,000, 0. 300x, you get 300. Minus 50x squared, it will be minus 100x. I give this equation number 4. Is that clear? The derivative here exists for any real number x, because it's a polynomial of degree 1. Polynomial of degree 1, it exists. Your derivative exists for any value of x. So I don't have singular point. So what do you have? Do we have a stationary point? Yes, we have a stationary point. Just equate the derivative. That is stationary point, right? Stationary point. So just equate the profit here, the profit to 0, right? And then go ahead and solve this one here for x, guys. You get 0 equals 300 minus 100x. If I solve this one here, you get 300 equal 100x. So what is your x? X3. Is 3 inside the domain? Yes, 3 inside the domain. What is your domain? Your domain here is 0, 10, the same, 0, 10, right? 0, 10, that is my domain, yes. So I have to make a table here, and this x here, but I have to write here the profit. That is your profit here, right? And then you have 0 here, you have 10 here, right? And you have 3 here, right? So what you'll do, what is the profit here? Equation number 3, that is equation number 3 here, that is the one. Just replace x by 0. If I replace x by 0, what did you get? You get 2,000. If I replace x by 3, just 3, so maybe I just write it here. So what do you have? I write here the profit when x equal 3. Just I go back to equation number 3. So where is equation number 3 here? This one here. So you have 2,000, and you replace x by 3. So you have 2,000, right? Plus, I try to copy this one. 2,000, 300 x. What is x? 3 minus 53 square. If I use technology for this, I got here 2450. 2,450. And now what is the profit? The profit here, when you have 10, when x equal 10, you go equation number 3, you have 2,000 plus 300 multiply by 10, replace x by 10, and here minus 50. And what is your x? Your x is 10 square, which is 100. 10 square is 100, so you get 0. You get 0. So from here, guys, from the table here, what is the maximum value you have? Or that is the maximum value. So that is our maximum profit. So the maximum profit here is 2,450 when x equal 3. What is 3 here? That's the number of vacant room. Does that make sense here? All right, so I hope it will be clear, guys, here. So now if I go to equation number 6 here, we try to read what is given here for number 6. All right, so maybe I'm going to escape here number 6. So I go for number, what is number here? Number 7, because it's all of them here, just to try to kind of repeat it somehow. All right, so if I go for number 7, if you have a bus company charge $10. All right, so here, for when you have that kind of application, go ahead and read the question. What is the question here? Oh, how many people will maximize the total revenue? So I need, your goal here is one, maximum revenue, right? So that is our, I need to get. And now they ask you how many people. So you have your variable here, number of people. So before I do that, let us read the story. So you have number of people, right? Number of people. So I know that revenue here should be price multiplied by quantity, right? The price multiplied by quantity. So now, what is your price? Go ahead and start read. A bus company charge $10 per person for sighting trip if 30 people travel in a group. If each here person above 30, the company reduce the charge per person by 20 cents. How many? So that is the question. So now I need to figure out what is my x. So x here, guys, when you look for the second part here, if for each person above 30, so x here, I need to figure out the number of people, right? The number of people above 30, because below 30 I know you will have it's known, so you need to look for above these numbers, right? So now I'm just saying x here. So now, guys, how many? The number here is, you have 30, the number here, the quantity here, right? The quantity here, what is the quantity? 30 plus x. So 30 plus the number above 30, that is to give you the number. What is the price? The price, they sell $10 if you have 30 people, right? And then after that, if you go above 30, it will be reduced minus, look what you have is written there, reduce me minus 20 cents, 0.20 multiplied by x, 0.20 multiplied by x, and that to give you the price. So $10, that is for the if you have 30 people. If you go up above this one, then you reduce by 20 cents. So that is our revenue here, guys. If I try to simplify this, just go ahead and expand the bracket. 30 multiplied by 10, you get 300, right? Plus 4x, right? Minus 0.2x squared. Let me give this equation 1. So I expand the bracket, and simplify. I got this one. So that is revenue? Yes, that is our revenue, right? So if I simplify this, I already simplified this one here. So I need to get the domain. How to get the domain? Look what you have here. This one here. What is the price? The price, you agree with me here, the price should be greater than 0. And quantity also. Quantity here should be greater than 0. What is the price? Oh, the price here is 10 minus 20 cents, 0.2 multiplied by x should be greater than 0. If I go ahead and solve this one for x, You have 10 greater than 0.2 multiplied by x. Is that correct? If I simplify this, what did you get? You will get x. You have 50 divided by 0.2, 50 greater than x. Divide 10 by 0.2, divide 10 by 0.2, you get 50. What do you know about x? Your x should be greater than 0. So what is my domain, guys? Here the domain here is 0, 50, 0, 50, right? You have 0, 50. So now the rest should be easy. How to get should be easy. How? Just you go ahead and find the critical point. What is the derivative of your revenue? So what is r prime? R prime here, just go ahead and take the derivative here. Equation number 1. What is the derivative of 300? 0, 4x, which is 4. It will be 4 minus, what is the derivative of 2x squared? You have 2x. So you have 0.2 multiplied by 2, or 0.2 multiplied by 2, you get 0.4. So you get 0.4 multiplied by x. So it's very clear, no singular point. Why is no singular point? Because your derivative polynomial of degree 1, it exists for any real number x, right? It exists here for any numbers, right? So here I'm just trying to see the, all right, so just here I try to see the, all right, so just no singular point. I need to get the stationary point. How to get the stationary point? Stationary point here, guys, stationary point. I have to, stationary point, just equate the derivative to 0. So if I equate that to 0, you get 0 equal 0.4x. If I simplify that, you get 4.4x. If I just go ahead and divide, so you have x equal 4 divided by 0.4. If I use technology for this, what did you get? What is your x? Is very clear, just 10. So your x here, your x equal 10, just 10. Is 10 inside the domain? Why, yes. What is the domain? 0 to 50. 0 to 50. All right, so now what is the end to finish this problem? I have to make a table, right? You have to make a table here. That is your x, and that is your r. And then you have 0 here, you have 50 here, right? And you have 10 here, right? So I have to go for equation number 1. Where is equation number 1? Here, r. Replace x by 0. If I replace x by 0, what did you get? You get 300. So I have to go back here, 300, all right? Then I have to get the value r here at 10. I have to go equation number 1. Where is equation number 1? Here, 300. I replace x here by 10. I replace x by 10. So you get 300, right? I'm just looking for the, so you have 4x. What is x? 4 multiplied by x, which is 10. 0.2, you have 10 square. I have to use technology for this. You get 320. When I use technology, you get 320. So now, what is the last one? The last one here is I need to get r at 50. So what is r at 50? So r at 50, you get 300 plus 4 multiplied by 50 minus 0.2, 50 square. Use technology, you get 0. All right, so what is the maximum value here, guys? The maximum revenue, look to the table. Oh, that is the maximum value. That is our maximum revenue. So the maximum here, revenue is 320 when x here equal 10. All right, what is x here? That is the number of people above 30. So what is the total number of the people then? You have 40 people. 30, that is when they sell the ticket 10, and then you have x here, that is the number of the people where it will be above 30 people. Okay, guys, so that is our maximum revenue. All right, so now we leave the revenue and the cost and the profit, and then we go for something very interesting here. It's more like something related to high school maybe. So let us look to what is written here. You have 3 rectangular corral, right? Each enclosing area of 600. So if I try to grab this one here, you have here like this, right? So you have here this one 600, and you have 3 600, and then you have here 600, All right. So here I'm going to assume, guys, so if you have 3 rectangular corrals, each enclosed area 600, so that is 3 channels. So that is the area 600 square meters are to be constructed in the diagram. That is the diagram is given here, guys. So that is the diagram is missing. So I graph this one here. Find the value of x and y and z. What is your z and what is your x and what is it? So here that is your x. Our x here from here to there, that is your x. So your x, that is the length here, x, and here, and that is our y, right? Our y. And what is z? So that is your y here from here to there, that is your y. What is your z? Maybe I use different colors. Different colors, red, this one here, right? So that is the red one here, that is your z. So z from here to there, right? So you have, that is your, just look for the colors here. All right, but I don't know. Okay, so here, so there's your x. So now let us look to find the value x and y. You need to get the value x, y, z, which will minimize the length of fencing. Look what you have, minimize the length of fencing required to build the recall. So I need to get the fence here. If I have a wiring here, I'm going to move around here. So what is the length of the fence here, guys? Can you tell me what is the length? I'm going to call it L. So what is our L here? How many x here? How many wire you have? Oh, you have here 1x and here 1x, 2, and 1x here. So how many x you have? You have 3x. 1 here and 1 here, 2 and 1, 3. How many y you have, guys? You have 2y. 1 y here and you have y. And also you have z here. That is your z. So how many z you have? You only 1 z. So if you have wiring, you move around this. So you have how many x? 1, 2, 3, 3x. How many y? Oh, y here and y there. So that is y and that is y, 2y. How many z? The red one. Oh, z here. It's this one. All right. So that is your L. So I need to minimize to get the minimum of this. What is the constraint I have? I have to look. Look what you have, guys, here. Your L, how many unknown or how many variable you have? Your L is a function in x and y and z. X, y, and z. That is the next chapter here when you go for several variables. But here, what we have learned, how to get the minimum or the maximum for single variable, only one variable. But here your L is a function in x, y, z. So now the idea how to make this one in one variable instead of 3 variable x, y, z, how to make it only one variable. So now how I'm going to do that? I'm going to use the fact, look what you have. What is the area? That's what is the area of rectangles? That is a rectangle, the area of any rectangles. Area, right? What is the area of rectangles? The area, it will be, if you take x multiplied by y equal what? X here multiply the whole rectangle, x multiplied by y. What is the total area? 600 plus 600 plus 600. So you have 1800. So let me give this equation 1. Number 2, x multiplied by y, that's give you the total area, right? So that is kind of relation between x and y. So now I have to look is for z. Z connect z with x, right? Or with something here. So I have here, if you take x multiplied by z, well, that's what this give you. You know, maybe I use different colors of blue. So if I look, so maybe green, so that you can see. If I use for the green one here, look what you have this area here, the green one. So what is your z? This part here, the red one, z. And what is the height here, or the length, or x? So x multiplied by z give you what? What is the total area here, guys? If you take x multiplied by z, you have 600 plus 600. So what did you get? You get 1200. That is equation number 3. If I look to this, why I'm doing so here, why I'm doing this kind of area here, because your L, your goal, what is your goal? To minimize L. I need to get the minimum length, L. But here your L is a function in x and y and z. So what I should do, I should write this in terms of just a function x, or function y, just one variables. And instead of 3 variable x, y, z, just I make it. So here, look what you have, equation 1, I can write y in terms of x. this one from number 2, right? What do you have from number 2? From 2 here, from number 2, I could solve that for y. If I solve for y, so solve for y, right? So if I solve for y, what do you have? You have y equal 1800 divided by x. Let me give this number. And when I solve for y, I wrote y in terms of x. Equation number 3, I could write solve for z. Solve for z. If I solve for z, what do you have? What is your z? Oh, 1200 over x. This equation one, number 5. So if I divide, I need to solve for z, means I divide by x, right? So if I divide by x, you have 1200 over x. So you have 1200 over x, and y 1800 over x. So you can ask why I'm dividing by x, because I know x is what? What is your x? Your x here is your x and y and z. All of them are length, right? Length, and any length it's wiring, right? Or for Vince. So that it should be greater than 0. That's the reason I'm able to divide by x, right? I'm able to divide because that's a length, and that it should be greater than 0. So now, if I go our goal 3x plus 2y, I need to get the minimum of number 1. I need to get the minimum. So what I should do, just to try to see here, your L is 3x plus 2y plus z. So now I have to replace y and z from equation number 4 and number 5. Look at that. You need to write everything in terms of x. You need to write everything in terms of x. You have 3x plus 2y. What is your y? 1800 over x. 1800 over x. That's come from here. That is your y. What is your z? Oh, your z is 1200 over x. 1200 over x. That is my z. If I simplify this one, you have 3x plus 3600, right? Divided by x. Divided here 1200 over x. Now that is your L, right? Is that our L? Yes. So now, guys, I need to what is the good news? The good news here is your L become now a function in one variable, x here, x here, x here. So now we are able to apply either first derivative test or second derivative test. You are able to solve this problem, right? You are able to solve this problem here, right? So how I have to get the derivative? I need to get L prime. The derivative, what is the derivative of 3x? The derivative of 3x is what? Is 3 plus. What is the derivative of this? The derivative of this, it will be, you could write this as 3x plus 3600. I can take x up there, you have x minus 1. 1200, I take x up, you have x to the power negative 1. Because here x to the power 1, if I take it up, you have negative opposite sign. So now it's easy to take the derivative. Derivative of 3x, 3. What is the derivative of this? It will be 3600, and this negative x minus 2. And here 1200, what is the derivative of x minus 1? That's 200, 1200 here, right? 1200. So maybe I just try to do so 1200. And here the derivative of this, it will be negative x minus 2. If I simplify this, you have 3 minus 3600. This one here, it's the exponent negative, so I can take it down. You have x squared. And what is this one here? It will be minus 1200 over x squared. I give this equation here. I just give a number, just any number here. So did I give 6 here? Okay, that's number 6. That is our derivative. So now let me ask you guys, do we have singular point? No singular point. Why? No singular point. No singular point, because your L prime at 0 does not undefined, right? Does not exist, undefined, because we cannot divide with 0. But 0, but x equals 0 is not in the domain. What is x? Is not in the domain, because x here, but I should is at x is 0, but here, but x should be greater than 0. Why? Because your x here is a length. And your length should be greater than 0. So we cannot have 0 inside the domain. So because of that, it's no singular point. So now how to solve this one? That is the equation. Take the derivative. I need to get stationary point. I have to stationary point, I have to equate that to 0, right? So what is the derivative here, guys? If I take the derivative to 0 here, just try to see, you have 3 minus 3600 over x squared minus 1200 over x squared, right? So some people can ask a question, can I combine those together here? Yes, you can. How to combine those together? If I combine them, it will be 3, just adding, so it will be minus 4800 over x squared. 3600 minus 1200, so minus here, and you have minus here. When I add those together, you get minus 4800. How to solve this? Take 3 there, you have 4800 over x squared, right? Divide by, by 3, divide by 3, what did you get? You get 1600. So what is your x? Multiply by x squared, so you have x squared equals 1600. If I solve this, you have plus or minus. Do not forget plus or minus. Square root of 1600. So what is this one here? So you have your x is 1. Your x equal plus or minus 40. But here your x here is a length. So we cannot have negative numbers. So what is your x? Your x here is 40, right? 40. So now they ask you, is that the minimum? Is this 40 minimum? Let us check first. Maybe apply first derivative test, right? That is your first derivative test. So here 40. So I have to check what happened for L prime here, L prime here, right? I have to check what is the L prime and the L prime, right? So look what you have, guys, here. So what is your derivative here? That is number 6. If you want, you can write number 6 here as 3 minus 48. Your derivative, if I simplify this, it will be 3 minus 4800 over x squared, right? Over x squared. So if you can simplify this, you can apply first derivative test if you want, or you can apply second derivative test. Either or, it will be, both of them show that it's a minimum. It's a minimum, right? Because what is the question? The question, they ask you what is the minimum. How to get the minimum here, which means this one should be decreasing and this one should be increasing, because I need to get minimum. The question finds the minimum length of the fence. Your L here should be minimum, so I need to get here, that's the minimum. How to show that? Take x, say, equal 10. L prime at 10, is that negative? And L prime at 10 at 50 here. So see, what did you get? If I go back up here, guys, here, if I replace x by 10, what did you get? You get, if I replace L by 10, you get 100, so 2 0 cancel. So what did you get? You get negative number. So your derivative here is negative. Negative means it's decreasing here, decreasing, right? If I go for 50, so what do you have? You have, right, what is the derivative? Let me look to number, the equation 3 minus 4800 over x squared. So you have 3 minus 4800 over x squared. What is your x squared? X squared here, it will be 50 square. If I simplify this, right, so you get 3 minus 4800 over 1. Just try to see that. If you can use technology here, it's very easy. 50 square, which is 2500, so 2 0 cancel, is 2 0 here. This 48 over 25 plus 3, get something positive. So here is L prime greater than 0, positive here, right? Positive, and here negative, so you have minimum. So we have, that is minimum length, right? Your L minimum at x equal 40. But they ask you the dimension. What is x? What is y? What is z? How to get x and to get, here x is 40. How to get y? It's very easy. You go to equation number 4. That is a relation. If I replace x by 40, you get y. Equation number 5, if I replace x by 40, you get z. So now, if I put that in equation, let me show you here. If I put x here, 40 in equation 4, so what do you have in equation 4? You have your y equal 1800 over x. So what is 1800 over 40? So 0 cancel with 0. So what did you get for y? Somebody, you can use technology and tell me the number here. What did you get for y? You get 45, right? So now I need to get, I put x equal 40 in equation number 5. What is equation number 5, guys? Equation number 5, your z, to get z, which is 1200 over x. 1200 over x. What is x here? Over 40. So 0 cancel with 0. So you get 30. So what is so your x? You get x 40. X equal 40. And your y equal 45. And your z equal 30. All of them, the unit of this is feet, right? The unit of this is feet. So that is a problem here, guys. So this one, it's hard, the problems, but it's a very, I want for you to understand this kind of problems. If you have a question, you can stop by in my office to ask. So the graph here is given to you. Sometimes we ask you the same problems, but here instead of x, we can say we have a river here. If you have a river here or highway, it's open. Then if I repeat the same problem, but you have a river or highway, then your x here, how many? You have 2x. This one, if it's a river, no fence here, then what do you have? You have x, 2x. Instead of 3x, you have 2x. One here, one here. If you have here river, or you have highway, sometimes you ask the same problem, but I have high rivers or highway, then you just the fence here, you go around which side. Oh, here I can go here, I go here, I go there. But if you have a river, I cannot go here for this river, right? So that is very much that I have for this one. All right, so I think that is number. I hope it will be clear. Maybe I solve another one, but it's very much we repeat the same problem. So let me solve this one here, and the number 10 here, I could put the solution. You can check it yourself. So here I give you the graph here also, or maybe just 1, 2, 3, 4. So here, just let us read the problem here. What is the largest? Look what you have. The largest means absolute or global total area. So they ask about the largest mean global, right? So possible total area of the 4 bins. So you have 4 bins here. What is the farmer? A farmer with 750 meters fencing. So the fence here, if I write this one here, guys, x here, and here y. So you have here x, you have here y. So what is the fence here? The fence here 750. How many x you have? 1, 2, 3, 4, 5. So how many x here, guys? You have 5. 1, 2, 3, 4, 5. 5x, because you go fence around all of this. How many y you have, guys? Here you have 2y. You have 2y. Is that make sense? So you have 750 from wiring or fence here. So you go around all of this. So you have 1x, 1, 2, 3, 4, 5. I have 5x. How many y? You have 2y. All right, that's equation number 1. What is the question here? The question, they ask you to find the maximum area. What is the total area? The total area here, you have to add all this, the maximum total area. So what is your area? It will be the area here, maximum area, x multiplied by y. So x, what is the total area? X, if you take x multiplied by y, you get the total area. Now, how to get the maximum of this? X multiplied by y. Your area is the function in 2 variables, x and y. Your area function in 2 variables, x and y. So here, that is equation number 2. So what I should do, I should make this in 1 variable, not 2 variables. So how to do that? I have to use the equation given here, number 1. That is equation number 1 is given. So what I'm going to do, you go back to equation number 1, go ahead and solve for x or for y. If I solve equation number 1, solve for y. If I solve for y, what is y here? So you have 750 minus, take 5x to the left, you have minus 5x equal 2y, right? Minus 2y. Then go ahead and divide by 2. Divide by 2. If I divide by 2, you get 750 minus 750, right? Minus 5x divided by 2. So I give this equation number 3. So now I solve for y. Y equals 750 minus 5x divided by 2. Then what is your goal? The area, which is x multiplied by y. Then I can replace y from number 3. X multiplied by y from number 3. That is your y. So you have 750 minus 5x divided by 2. Divide by 2. Right? So what I have to do here, go ahead and simplify this. You get 750 multiplied by x, right? Multiplied by x minus 5x squared, the whole thing divided by 2. If I want to simplify this here, guys, I could simplify 750 divided by 2, you get 375. X 5 divided by 2, 5 divided by 2, you get 2.5 multiplied by x squared. This equation number 4 here, right? That is your total area here. So now I need to get the critical point here, guys. I need to get the critical point. But here, some people can ask, is they say, well, can I find the domain? Because when you say, you give us a hint here, when you say largest mean absolute or global. Then when you have absolute or global, then you have your domain must be closed interval or half closed, right? The closed interval. How to get the closed interval? Look what you have, guys, here. So here, what do you know about x? Your x should be greater than 0. Your y should be greater than 0 because they are length, right? So what is your y? Look what you have from equation number 3 here. Equation number 3, your y, 750 minus 5x over 2. That is your y should be greater than 0. So I should write it here. 750 minus, I forget, 750 minus 5x over 2 should be greater than 0. So now I need to solve that for x. Multiply by 2, you get 750 minus 5x greater than 0. So how to solve it? Take negative 5x to the other side, you have plus 5x. Divide by 5, so what is your x? You will have 150. Your x is what? 150. But what do you know about x? Your x should be greater than 0. So what is the domain? 0 and 150. So you have 0 and 150, right? You can write here 0 and 150. Here you require x greater than 0 because if it's 0, then you don't have, the area will be 0, right? The area will be 0. So you require x must be greater than 0. All right, that is our domain. Yes, that is our domain. So now I need to get the critical point. What is the critical point? That is your area. I need to get the, go ahead and take the derivative. Go ahead and take the derivative. What is the derivative, guys? Go ahead and take the derivative of this. It will be, what is the derivative of 350x? It will be 375. What is the derivative of x squared? 2 multiplied by 2.5, you get 5x. Right. So if I take the derivative a prime, it will be 350x minus, right? I'm just looking for the problem, minus 2.5 x squared prime. If I take the derivative of this, what did you get? The derivative of this, you will get 375 minus 5x, that is a prime. It's very clear, no singular point. Why no singular point? Because this one here is polynomial of degree 1. Polynomial of degree 1. So now there is no singular point, right? So now do we have a stationary point? Yes, a stationary point takes the derivative equals 0. So you have 375 minus 5x equals 0. So you have 5x. What is your x? Just go ahead and divide or solve this one. So what you have, your x here is 375 over 5. If I use technology for this, I got here x equal 75. Your x here equal 75. All right. So now, do we have minimum or maximum? Right. So here your area. So it's 75. I have to look for the area, the derivative before and after. Right. So what is the question, guys? Here they ask you about largest what? Largest, the maximum total area. So I try to maximize the area. Maximize the area means I need to get the maximum here, right? So which means you are expecting this one should be up and this one should be down. This one should be greater than 0. This one should be less than 0. Let us check. Let us check because it might be, you have to check, right? So that is, so let me check this one here. How to check? You take what is a prime at 50. What is a prime at 50? And here, what is a prime at 100? What is your a prime, guys? Oh, here, that is equation. You just give a number. I try to follow the number here I gave, 4. So maybe I give here number 5. That is my derivative. In equation number 5, just replace x by 100. If I replace x by 100, what did you get, guys? 100. 375 minus 500. When I replace x by 100, you get 500. So you get negative numbers. So that is a negative number. That is correct. This one here is decreasing. Now, if I go for 50, what is a a prime at 50, just go equation number 6 here. Where is number 6 here? 375. So you have 375 minus 5x, which is 50. If I simplify this, you get something positive. 375 minus 250, you will get 125. It's a positive. So yes, here it's what you have maximum area, the maximum area here. How to get the maximum area, guys? What did you get here, guys? I got here x. What is your x? X here, we get x 75. That is where you have max. I need to get y. I need to get y. How to get y? Because your dimension x and y. What is the relation between x and y? Here, look what you have. You can put it in equation number 3. Equation number 3. If I replace x by 75, I get y. Right? Or you can put it in equation even number 1. If I replace x by 75, you can also are able to solve for y. For make it easy here for number 3, it will be easy. So if I put that in number 3, right? If I put that in equation number 3, so you have 750 minus 5x divided by 2, right? That is the equation here. So let me check. So you have 750 minus 5x over 2. So now, what is, you have 750 minus 575 divided the whole thing by 2. Just use technology to get the number here, guys. I got here y equal. I just try to see if I have here y. I think I just use technology to get y, so that is give you y. So what is the area here, guys? The area, I don't have the technology here, so you have 750 minus 5 multiplied by 5, so you get 5. So you get 375 divided by 2. So that is your y. So what is the area? The area here is, you can compute area x multiplied by y. That's give you the maximum area where x equal 75 and y here the value that you have from here. Or just go back to equation number 4. Equation number 4. Equation number 4, if I replace x by 75, you are able to get the maximum area, So if I do that here, if I put, I am going to give you, put that in equation 4, guys, put that in equation 4. Then your maximum area, your A maximum here, it will be, just to check that, 4062.5, that is feet square, so 1406.2. How did I get that? Is equation number 4. So if I go back to equation number 4 here, where just go ahead and replace x by 75. Replace x by 75. Use technology, you will get this number that I'm talking about, which is 14062.5 square feet, right? Square, that is kind of largest value. That is our largest value. All right, guys. All right, so I will stop here, and the rest of the problem here I'm going to provide the solution to. And please, if you have any question, you can stop by in my office. Thank you. All right, thank you.